Do you know you can solve this question in less than 60 seconds? Let me show you two methods you can use to solve this question. The question goes like this: if the electron configuration of an element is 1s2, 2s2, 2p5, how many unpaired electrons are there? A2, B5, C1, D4. So let's do like this. Let's say here you have our method 1, and here you have our method 2. So for this method 1, let's get out the electron configuration. You have 1s2, 2s2, 2p1, 2p5. So in this case now, you are less concerned about these two orbitals, 1s2 and 2s2. Let me focus on this 2p5. So now, you now check this 2p5, you're now going to draw the orbital diagram. So if you want to draw the orbital diagram of this 2p5, what you need to do is that, how many suborbitals do you have in these p orbitals? To know the number of suborbitals you have in p orbitals, you are going to use the formula that you have 2l plus what? Plus 1. Where this L, we call it what? Azimuthal quantum number. Quantum number. Sometimes they call it subsidiary quantum number. And each orbital has their own L value. For example, X is 0, P is 1, D is equal to 2, and F is equal to 3. So in this case, you are looking for what? P orbital. That means you are going to use 1. You are going to have 2 multiplied by 1 plus 1. 2 multiplied by 1, you are going to have 2. 2 plus 1, you are going to have what? We are going to have 3. So in this case now, you can now draw the energy diagram that in this case, that's we have 2p5, and in this 2p5 divided into 3, we have ps, py, and pz. So the question now is that, am I going to put the electron randomly? No. We are going to use, there's a rule called Ohm's rule, and this will state that the electrons enter the generated orbitals singly before the pairing commences, which shows that I first put one electron here, one electron here, one electron here, making how many? 3. Remain 2. I put 1 here, I put 1 here, making 5. Remain this one. Now check from this diagram now, which one is not paired? It's only this one that is not paired. We saw that in this case you have one unpaired electron. So which shows that our correct answer here is what? Option C. Let's check the method 2. In this method 2, what I'm going to check is that you have the formula. The formula goes like this: the number of unpaired electron. So, and in this formula, you have two cases. The first case is that if the numbers of electrons in that orbital is less than or equals to the number of electrons the maximum number of electrons that orbital can accommodate. What I mean is that, for example, now this p orbital can accommodate maximum of 6 electrons, and we have formula for that to calculate that. And the half of this p is what? Is 3. If the number of the electron here is less than or equals to 3, you have the formula. The formula is that the unpaired electron is equals to the number of electrons you have here. I don't know if you are getting it. The second one is that if the number of electrons you have here is more than half of the maximum number of electrons that orbital can accommodate, what I'm going to do is that now say the maximum number of electrons minus the number of electrons here. That means we have mass electron minus number of electron. I don't know if you are getting. Let's take this one as an example. So in this case now, if you want to calculate the number of unpaired electron, you have 2p5. You know these p orbitals, and you know that in these p orbitals can accommodate maximum of 6 electrons. So which means you now check here, and the half of this 6 is what? Is 3. Is this number of electrons you have here, is it less than or equals to 3? If it's less than or equals to 3, you are going to say that the number of unpaired electrons is equal to the number you have here. But if it's not equals to or less than 3, what you are going to say is that you are going to say maximum number of electrons minus number of electrons you have in this orbital. For example, now in this p orbital, the number of electrons you have here is 5, which is more than what? Is more than the half of the maximum number of electrons. So in this case now, I just say 6 minus 5. 6 minus 5 is equal to 1, which means you still get 1, 1. That means there's no need for you to be drawing the diagram. But what if the case that you have number of electrons that is less than or equals to 3? For example, now let's say in this case you have 2p2. What I'm going to do here is that they say what is the number of unpaired electrons you have in this kind of case. What you're going to do is that so far the number you have here is less than or equals to the half of the maximum number of electrons this can accommodate, it shows that the number of unpaired electrons is equal to this. That means equal to 2. Which of these two methods you find simpler? Drop it in the comment section. And if you find this class interesting, like it and share it to your friends so they can also benefit from it.